Hey everybody, this is Mr. Aynesworth, and we are in MRWC here together here today. And we're going to go in through a little practice here on activities 7A, 4, and 5. Now we've already been through the activities, and what we're going to do is just practice. And this is Desmos required, so get your Desmos ready to rock here. So let me show you what I'm talking about here, because I have Desmos up and running as we speak right here. So get your Desmos account up and running, log into it, and get ready to enter some functions in like I have up here, and we can get right into a good discussion on how to find vertical asymptotes, holes, domain, all that sort of thing. Okay, all right, so let's get right into it. So I've got my Desmos on the right, I've got and you should have Desmos as well. And then I've got our activity or our practice on the left. Okay, so let's get right into it. Okay, number one, we have a function that looks like 1 divided by x plus 4. This is a rational function here, and because you guys know that we cannot divide by 0, all right, you got to figure out where it's undefined, because rational functions have restrictions. Okay, and by that I mean that it's the domain is not all reals. It's all reals except wherever it's undefined. And this function here is undefined at -4 because -4 plus 4 is equal to 0. Okay, so you want to focus in on the denominator here, and you want to be looking at, where is x plus 4 equal to 0? Well, it's obviously when x is -4. So it's undefined at x equals -4 because that's the point, okay, or value of x that make the function undefined, right? -4 plus 4 is equal to 0. 1 divided by 0 is undefined. Okay, 1 divided by 0 is undefined. Okay, you're going to see that when we graph it in Desmos as well. You're going to see a vertical asymptote there because we cannot factor or simplify this. So this indicates that we have a vertical asymptote, not a hole, but a vertical asymptote. Okay, at what's called x equals -4. You're going to see that on the graph. Okay, so the domain, though, the domain is all reals except that number. So in just real language here, in words, all reals except, keyword except -4, or in symbols, x not equal to -4. Okay, where x is any real number. Okay, so it's undefined at -4, which means the domain is all reals except that value, except -4. And because we can't simplify or remove the discontinuity, okay, we do not have a removable discontinuity here because we can't simplify it. We do not have a hole, but we do have a vertical asymptote. So if we go to the graph here in Desmos, you guys can type it on your own, and you should pause the video and type this in. You'll see that we have a vertical asymptote at -4. You just got to zoom in a little bit here. So let me do that. So it's kind of hard to see it because vertical asymptotes are invisible, right? They're imaginary lines that the functions approach. So we go ahead and type it in. Type in x equals -4, and you'll see the vertical asymptote appear. So if you sketch along the function here, trace along the function, you'll notice that as we approach -4 on the right-hand side, looking at the right side behavior here, the function goes to positive infinity. On the left side, okay, as you approach -4 on the left side, the function goes down to -infinity. Okay, and that's called the behavior of the function values. So I already know, okay, just based upon what I just said right there, that from the left, as x approaches -4 from the left-hand side, okay, y approaches -infinity because the function goes down, okay, without bound, okay, there's no end. And so we say y approaches -infinity. They decrease without bound. On the right-hand side, some difference happening. Okay, on the right side, as you approach -4 from the right, the function values go up without bound. So that means that as x approaches -4 from the right, all right, y approaches positive infinity, which means they increase without bound. Okay, so the function is undefined at -4. So take a look at the table here; it's undefined there. To see that, what you do is you take a look at the function, click on the gear, all right. Duplicate the function and then change it to a table and then put in the correct values. And so I'm going to just omit all these values And I'm going to go down a couple spaces right here. I'm going to put in -4. You'll see it's undefined there. Okay. Now I'm going to come in from the left of 4. So if you're left of 4, that means you want to be in the immediate neighborhood of -4. You got to be really close to it. And so -4.1. Okay, type in -4.1. That's pretty close. Okay. And notice it gives you a function value of -10. Okay, well, let's get even closer. Let's go -4.01. That's closer to -4. Okay, and notice the function value is -100. Well, let's get even closer. -4.0001. Okay, and so notice that the y values are decreasing right here from -10, -100, -10,000. Okay, that's what it means to go to -infinity. Okay, to get infinitely negatively big. Okay. Now, when you go beyond on the left side, or excuse me, the right side of 4, okay, you want to, let's go down a couple spaces here. -3.9 would be close. Okay, that's pretty close to -4. Let's get closer, -3.99. All right, let's get closer, -3.999. Okay, and let's get even closer, -3.999. Okay, notice that the y values are getting infinitely big. From 10 to 100 to 1,000 to 10,000. That's because as you get closer to the asymptote, the y values just sky upward, okay? And they go to -infinity. And those are the values, these are the values that you want to put in your table. So you just go ahead and sketch them in. So, okay, so I see a -4.1, okay? That gives you y value -10, and then -4.01, okay, -100. So use Desmos to your advantage. All right, you put the values in, all right, and it will help you evaluate the function. Okay, now that's to the left side of 4. Okay, on the right side of 4, okay, -3.9, the y value is 10, -3.99. Says right here the y value is 100. Just record your work here, guys. It's not that hard. Okay, and then you get 1,000, and then -3.9999. All right, you get 10,000. So when you're coming in from the right side, notice that the y is approaching infinity. So right here on the right, okay, right here, y is approaching infinity. On the left side, y is approaching -infinity. Okay, that's what I said down here when I talked about what's called the behavior. Okay, behavior of the function values. Look at this right here, behavior of function values. What's going on from the left and from the right. And then, obviously use the graph and sketch your function. So draw your vertical asymptote. All right, and then draw your function. Look how easy this is just by looking at the graph. Just a quick sketch. So I'm doing this in seconds. All right. Okay. So when you're coming in from the left-hand side, the function's decreasing without bound. That's when you go in this direction. When you're coming in from the right side, the function's going up, not down. Okay, and that's dealing with the behavior. Okay, so with that in mind, let's turn off these colors here, and let's switch functions. Okay, so let's talk about what happens when you have the second one here. Y is equal to x minus 3 divided by x squared minus 9. You always factor and simplify a function if possible. So let's put that in here. So factor and simplify. Okay, always do that. Because when you can simplify a function, it indicates that you have a whole versus an asymptote. So the numerator can't be factored, but the denominator can. So it's x minus 3 times x plus 3. It's what's called a difference of squares. And notice that these cancel out, which indicates that you have a whole at 3, because that's what makes that undefined. Okay? 3 minus 3 is 0, so you have a whole at 3, not -3. So let's just note that. So we have a whole at x equals 3, so it's got to be 3 comma something. You can't find the y coordinate until you write down the resulting function. All right, so the resulting function here is going to be 1 over x plus 3. So y is equal to 1 divided by x plus 3. There's your simplified function. So you take 3 and substitute in there, and you get 1/6. So I know where the whole is. Now, the function is still undefined at -3. So it's undefined at positive 3, but it's also still undefined at negative 3, and that's what, right here, okay, that's what tells you you have a vertical asymptote at negative 3, because it's undefined there. And you can't remove it, you can't simplify it. So you have a hole at positive, x equals 3, positive 3, you have vertical asymptote at negative 3, and you're going to see that in the graph. So it's discontinuous or undefined at two different numbers, okay, at x equals negative 3 and positive 3, or you can say plus or minus 3. So the domain is all reals except those two numbers, all reals except, okay, x equals plus or minus 3. That's how you say it in words, okay? Okay, so let's go ahead and produce the graph. So let's graph it here, and let's take a look at it. And let's go ahead and notice it says in the table of values too, because I already created the table. And you just go up to the gear and then duplicate and make it a table and put whatever numbers you want in there. I've already put negative 3 and positive 3 in because I know it's undefined there. I want you to see it in the table. And then go ahead and type in x equals 3 for your vertical asymptote, and then type in your hole, and you can see where that's located on the graph. Let's make it a hole though. Okay, so let me see. Turn off your points in the table. So you can see a hole at negative 3 comma negative 1/6. Oh, hang on here. What happened? What'd I do? 3, 1/6 positive. Oh, I made a mistake somewhere. Where did I do it? Oh, I put in the wrong sign, so I got to put in 3 comma 1/6. Okay, so what's going on here? Aynesworth 3. Did I put the right function? Oh, I don't even have the right function in. I got to type in the right function. It should be x minus 3. Sorry, I knew I made a mistake somewhere. Okay, and then the vertical asymptote at negative 3. Okay, so I got to put in the right function. So there we go. Now things are looking good. Okay, so here we are. Okay, so now everything looks correct. So we got an asymptote at x equals negative 3. We got a hole at negative 3 comma negative 1/6. No, I got to change the title. Got to take out the minus signs. So let me do that. Excuse me for a moment. Okay, so let me put in the correct signs here. I don't know what happened there. Okay, there we go. Now it all makes sense. Okay, so we have a hole at 3 comma 1/6. You can see that on the graph now. So you wanna graph the asymptote first at negative 3. Okay, and then you want to plot the hole at 3 comma 1/6 right about there, and sketch the function. Okay, so I sketched the function, sketched the vertical asymptote. It's undefined at 3. Coming in from the left side of 3, the function is going down without bound, or the left side of negative 3, excuse me. So it should be, say, undefined at negative 3. So as x approaches negative 3 from the left, y is going down, so it's going towards negative infinity. On the right, the function is going up. Okay, so as x approaches negative 3 from the right-hand side, y is approaching positive infinity because it's going way up. All right, now in the table, let's put the right values in the table. So I'm going to cancel all these out and put the right function in here too. Okay, so there we go. So let's go back to our table here. And let's type in negative 3 as a reference point. It's undefined there. And let's go to the right of negative 3, like negative 3.1, for example. Okay, how about negative 3.01? How about negative 3.001? How about negative 3.0001? Okay, so you notice how the y values are getting infinitely big in the negative sense. Okay, it goes from negative 10 to negative 100, negative 1,000. They're decreasing without bound. Okay, and then if you want to put another one, you can. Okay, You can put as many zeros as you want. So they're getting infinitely negatively big. Okay, the function's going to negative infinity there. And then on the right hand side, let's get close on the right hand side. So negative 2.9 is pretty close, not very close. Negative 2.99 is closer, and then negative 2.999 is even closer, and then negative 2.999, whatever, you can do it as many nines as you want. That gets even closer. All right, so you notice the function values there. Okay, make sure you hit the save button too, by the way. And then just go ahead and plot it. So negative 2.9, the function value is 10. Negative 2.99, function value is 100. Negative 2.999, function value is 1,000. Negative 2.99999, okay, it's 10,000. And then the last one, negative 2.99999, it's 100,000. Okay. That's on the right side. On the left side, negative 3.1, the function value is negative 10. And then negative 3.01 is negative 100. And just look at the table of values here. Negative 3.001. All right, we're talking about negative 1,000. And then negative 3.0001, negative 10,000. So you guys, if I can do it right here in front of you, you can do it too. You just enter the function in, learn how to change it to a table, and then learn from it. Okay, when you're coming on the left hand side of negative 3, okay, left hand side, this way right here, the function goes down, so it's going to a negative infinity. Okay, that's what I said first. When you're coming on the right side, okay, the right side, the function is going up. All right, so that's why I said it's going to positive infinity, because it's increasing without bound. Okay, positive infinity. All right, so you just experienced a function right there that has both a whole and an asymptote. Okay, so sometimes they have both. Sometimes they only have one of each, or one of either one of them. Sometimes they have both. Sometimes they have none. Right? It all depends. You just got to go with the flow, guys. Okay, on the next one here, you got to factor first. So we got to factor into binomials. All right, so two numbers that multiply to negative 45 and add to, let's say, negative 4, middle term. How about negative 9 and 5? Okay, so negative 9 times 5 is negative 45, and negative 9 plus 5 is negative 4. So I'm going to factor this as x minus 9 times x plus 5. Okay, all divided by x minus 9. And notice that the x minus 9's cancel, which means that we have a whole, okay, at 9 comma something. Okay, and the resulting function is a very simple one. Y is equal to just x plus 5. It's a linear function. So when you analyze this one here, you're going to see a line. So let's take a look at it. So turn off your colors on all the other functions like I'm doing right now. Okay, and then let's type in your function here. Okay, so type that in. And you notice that we have a line here. Okay, so I'm just adjusting the scale a little bit. So where's the whole? Well, if you take 9 and add it to 5, you get 14. So it's at 9 comma 14. So let's go ahead and note that. So notice if you trace over it, you'll see it says 9 comma undefined. Okay, because, well, you can't divide by 0, right? 9 minus 9 is 0, and you can't divide by 0. So it's undefined at 9. It's discontinuous at 9. Undefined and discontinuous means the same thing. And so here the domain is all reals except 9. Except 9. Except is a key word, okay? All reals except 9. Because it's undefined there, so put that in your table. So what happens when you approach it to the left, and what happens when you approach it to the right? So let's do that. So let's go on the left side. So 8, let's see here. Let's leave some space. Let's get close. Like 8.9 is close. All right. Let's get closer. Hang on. So what's closer? About 8.99. Excuse me. That's on the that's on the left-hand side. So and then let's get closer. So 8.999. Right. Let's get even closer. 8.999. And notice that the y values are getting bigger, they're getting closer, but not by much, okay? All right, if you want to try this one more time, just go for it, 8 point, put a bunch of 9s in there, okay? You're going to get very, very close to 14. The y values, as you get closer here to the hole, the y values approach the y value in the hole, which is 14, okay? And so on the other side, though, let's go on the other side, the right side. The right side, if you're a little bit bigger than 9, okay? How about 9.1? 9.1 is close. Let's get closer, 9.01. Okay. Let's get closer, 9.001. Let's get closer. And how about 9.00001? That's even closer. So notice that the values here, they get smaller and smaller and smaller, 14.1, 14.01, 14.001. They get smaller, but not by much, and they get closer to 14, because if you're coming on the right side of the function here, on the right side of the hole, and you get closer and closer to the hole, the y values decrease until they approach the y value in the hole, which is obviously 14. Okay, and so we just have to put those values in. Okay, so at 9.1, okay, we get 14.1. At 9.01, we get 14.01. 9.001, 14.001, and then 9.0001, 14.0001, and then the pattern continues. And then the other side, if you start off at 8.9, you get 13.9. 8.99, you get 13.99. 8.999, you get 13.999. You get closer and closer to 14, and it just keeps on continuing. So just use your table. You have a hole at 9, 14, so go right 9 at 14, plot a hole, okay, and then your y-intercept error is at 0, 5. So here's your line. Just sketch it, and there's your hole. So not too hard. So when you're coming in from the, let me see, the hole's at 9. So there's 9. When you're coming on from the left, the y function's the function's increasing. So as x approaches 9 from the left, y is approaching 14. When x approaches 9 from the right-hand side, your function's decreasing, right? And again, look at the function value. It's y is approaching 14 on from the right, because you're decreasing, you're getting closer to the hole. Okay, so there's no vertical asymptote here. Okay, it's because it results into a linear function, and linear functions can't have vertical asymptotes. Okay, my friends, that is a good review of a lot of the concepts that we've studied in sections 4 and 5. So there you go. Take a look at what we've got there. Practice, make sure you understand everything fully. All right, and I'll see you in class. This is Mr. Aynesworth in MRWC here at Great Oak High School. Talk to you soon. Bye-bye.